Hello students, collector to base biasing circuit. In this circuit the base voltage is obtained, so let us write here base voltage is obtained by connecting RB from collector to base, that is, earlier we have seen like how this fixed bias circuit diagram will be just like this. Okay, so let us consider again so let us paste here. Okay, so in this circuit this is the fixed bias circuit. We will convert this to collector to base bias circuit. Collector to base means we have to connect the base resistance from collector terminal to base. That will be goes like this. This will be the NPN transistor. So this is the base resistance. So now the base resistance is connected to the base terminal. Earlier we have connected this to collector. Now it is connected to base. So this is the collector resistance, this will be the base resistance, this is the base current, this is the collector current. Now what is the current flowing through this part will be? Now what is the current flowing through this part will be IC plus IB, and this emitter is connected to ground. So emitter voltage will be always 0. Emitter is connected to directly ground, no? Then what is this? Is the collector voltage? Yes or no? Collector, base, emitter. Now if you apply the KVL from this point to this point between this loop, okay, So what you get here is, if you apply KVL, so this is the collector to base biasing circuit. So in this circuit, if you apply KVL here, if you apply KVL, if you apply the KVL over this loop, then what we get here? Minus VCC plus what is the current flowing through this RC is IC plus IB into RC plus VC is equal to 0. Yes or no? Now what we require to find here? VC value. That implies VC is equal to VCC minus of IB plus IC into RC. Okay, this will be the collector voltage. Then what about the base voltage? Yes or no? What do you mean by base voltage? This is VBE. Yes or no? This is the base voltage. To apply that, what we require to find here? Can we apply the KVL over this loop? Yes or no? Then you get base voltage is equal to what we get? If you apply in that loop, then what is the base voltage we get? Base voltage is equal to the VC minus IB into RB. Okay. Then what is emitter voltage? Emitter is directly grounded. No. So emitter voltage will be 0. Now if the base voltage is more than the base voltage, now some points will be like here. If the base voltage is more than the emitter voltage, then the emitter junction will be in forward bias, and if the collector voltage is greater than the base voltage, then collector junction will be in reverse bias. If JE forward, JC reverse, means this is nothing but transistor operates in active region. Transistor operates in active region. You have to remember these points. Okay. Then what do you mean by stability factor? Stability factor is defined by 1 plus beta divided by 1 minus beta into dou IB by dou IC. Okay. Then what we get here for the stability factor? Stability factor is nothing but if the value of the collector resistance increases, that implies stability factor will be reducing. So due to this smaller stability factor, IC collector current has a better stability. Better stability. Assume that as the temperature increases, assume as the temperature increases, then the reverse saturation current will also increase, due to which the collector current will also increase. Okay, due to the increase in collector current, the base current will be what? Due to the increase in the collector current, the base current will reduce. So due to the decrease in base current, the increase will cause the decrease. Now the collector current will reduce. So due to the temperature increases, reverse saturation current increases. Due to reverse saturation current increases, collector current or output current will increase. So due to this increase in collector current, base current will reduce. Due to the decrease in base current, collector current will always automatically decrease now. Okay, this increase causes the decrease. This increase causes the decrease. Okay, that implies then how can you find the value of IB? How can you find the value of this IB? IB current is nothing but, you can apply the KVL in this loop. Then what do we get the value of IB? IB is equal to what? VCC minus VBE divided by RB plus RC. Okay, minus IC into RC divided by same RB plus RC. Okay, how we got this value? You apply the KVL in this outer loop, it will get easily, no? Minus VCC plus IC plus IB into RC plus IC plus IB into, not IC plus IB, plus IB into RB plus VB is equal to 0. You will get the same answer. Okay, so the initial increase in the collector current, so let me write here this point. The initial increase in the collector current gets cancelled by a subsequent decrease in the collector current, and thus the IC remains stable. So what is our job is to make this IC as a stable point, then only the operating point will be in the stable region, active region. This technique of maintaining the collector current stable by allowing the base current, IB to change is known as stabilization. Okay, so the drawbacks in collector to base bias circuits are, so the first point will be stability factor or stability of IC depends upon the value of the RC. Yes, so the drawbacks will be, the first point will be IC depends on RC. Okay, RC is smaller or 0 means the stability factor approaches to 1 plus beta and stability is loss. Yes or no? RC will approach to 0. Then stability factor approaches to what? Then stability factor approaches to 1 plus beta, and then stability will be what? Loss. Okay, and collector to base circuit has a negative feedback which reduces the voltage gain also. Second drawback is voltage gain is also reducing because collector to base has negative feedback. Okay.